Hello everyone, today we are in Villeurbanne, close to our offices, because I discovered a third. A place where many alternative constructions have been carried out, including a straw frame house, straw that insulates and supports the house at the same time. It's a great concept, it's ecological, it's economical. I wanted to introduce it to you, as it will interest many. Let's go see it all. Hello Matilda, you're the site manager here. Can you introduce us to the project a bit?
It's a building, a co-working space. We are in Villeurbanne, in the Gratis-Fielas district. And there you have it. It's a load-bearing straw building that we are building. We are at the end of the construction.
And it's the Villeurbanne Town Hall, or who hired you to build this house?
It's regulator of social housing rents and habitat, so it's a social landlord. So there are several large buildings that will be built on this plot. And actually, while waiting for this construction site, there are several series of projects that follow along the plot during the temporary occupation. Several projects feature objects that can be taken apart, including various containers. So the idea was to build a building with little pollution, low carbon footprint. So the load-bearing straw interested the architect, and that's why he contacted us.
And what is load-bearing straw? It's straw bricks actually. How does that work?
Well, that's it. It's straw bricks. That is to say, we stagger them like bricks we mason them without binder. So there's no cement where there's no earth. Between the beds, they are stapled. So we go up like this, 7 rows, we put a peripheral beam and we compress afterwards with this peripheral beam to in fact increase the mechanical resistance, the stiffness of the wall.
And so we say load-bearing straw because it's going to carry the house, it's going to be load-bearing walls, and at the same time it's going to insulate. There's no need to add insulation.
Yes, absolutely. In fact, straw is still a very good insulator. So here we have, I don't know if this means anything to you, but we're going to have a thermal resistance of 8.8. Yes, that's still very, very high. In summary, it's an excellent insulator.
Even in 2020, the limit is 8.8.
So yes, I think...
It's very, very good. It's very, very good. What? Yes?
Yes, we haven't done the calculations or a life cycle assessment, but we are certainly very good.
Well, you introduced me to the construction site a bit. We now find ourselves in the heart of this subject. So what type of foundation do we have under this straw house?
It's concrete piles, so it's holes dug in the ground into which we pour concrete. There are about 10 of them to support the building.
And on top of that, we can see that you've put a wooden slab. Is that right?
It's a prefabricated wooden slab that comes in 5 or 6 pieces. We didn't make it. It was another carpentry company. It's pre-insulated. It was also insulated in the workshop.
And it's filled with cellulose watts, that's right?
Exactly. It's newspaper and confetti.
So you didn't do the foundations either, you arrived. There were already concrete foundations. Isn't that oversized for a straw house? Or is it precisely a setup? It's still quite heavy and we need concrete foundations.
Yes, well, I'm not a concrete engineer, nor soil, so I couldn't really comment on the sizing of the foundations. But it's quite classic, actually. It doesn't seem to me to be oversized at all.
You would have done the same. You wouldn't have found another solution to avoid using concrete by...
Example? Let's say that to be compliant, it's hard to do without concrete. So I'm not used to doing without concrete, even though obviously it's interesting to think about other solutions.
I don't know if you're familiar with technopiles, for example.
Yes, technopiles. Me?
I built my house like that, where I put the technopile and a container on top. There, it could have been the case too. Technopile, the insulated wooden slab, and then on top the straw house.
Absolutely, it depends on the soil. The technopile is not suitable for all types of soil. Here we have a backfill soil actually, because here there were houses not so long ago. So it's a backfill soil. So I know that backfill soils are quite complicated for foundations. That's all I can say.
So you arrived, the foundations were there, you put your insulated soil, and then we'll see the part, straw, the body of the house. You have this wooden slab with your straps, you lay your straw bricks, you tighten.
It works. How does all this? So the first row, we see a little bit the first row of straw bales. We encase it in wooden stakes. Each bale is taken on 2 stakes. The stakes are actually broom handles that we carve into points. So we encase the first row, then we go up like this, row 2, 3, 4.
These ones, they are therefore stacked in.
A stick, yes, they are simply stacked. No, simply stacked, yes. So always with the cross joints, we still read a little bit of the joints here. You say staggered, that's it there, staggered. It's important for the solidity of the wall, because if we had all the joints along the entire height of the building, obviously it would weaken it. So we cross the joints well. And on the 4th row, again, we pin, but this time with large pins that are 20 meters. And that we come to plant with a mallet. And they come down to the first bundle. Afterwards, we come to put the top rail, a big ladder, a little bit like the one at the bottom, but higher. We come to close the straps on this rail. And it's thanks to this rail that we compress the entire wall at the same time. And that we come to make a horizontal plan to be able to put the floor on this rail. Here we are going to put an interior and exterior coating. It's a bit special because the building does not stay very long. So we can afford to put a clay coating. We can't put clay coatings outside everywhere.
Otherwise, it would have been a hot coating rather.
Rather a hot coating, that's it, there you go.
And the coating, what does it allow on top? It allows to preserve the straw?
Well, there are several rolls. There is the roll, the gunshot, because at the regulation level, we cannot leave a straw wall like that.
Indeed, you put a lighter, we talk.
Even though, indeed, there are a lot of misconceptions about fire and straw, okay? In fact, straw bales burn quite poorly. There's little air inside, but when it's bare like this, it still catches fire easily. So once it has a fire break, really, it's not a good fuel, and so we come to put a coating on it. So the coating, it's fireproof. It prevents rodents from getting through, it provides water tightness, and it allows for air tightness on the inside. So it's really a super interesting material. It also helps to regulate humidity because the clay absorbs the humidity and then releases it later. So it also makes a great hygrometric buffer. There you go.
And so here we just have 7 straw bales that make up the height, but we can make houses on 2, 3 floors, right?
So in small bales, we make R+ without any problem. We have never made R+. We are looking for customers.
That's it.
The big bundle includes R+3 in Switzerland, R+2 and R+3, which have already been implemented.
And in terms of self-construction, would you say that load-bearing straw is something that is quite accessible, or is it a technique that still requires quite efficient skills? Could I, in self-construction, build my house out of straw, for example?
Directly, I don't think so. But if you take a small training course, yes, there is no skill that requires 10 years of practice, 5 years of practice. But on the other hand, there are still things to know, especially about the assembly of boots. The cleanliness of the assembly, in fact, is very important. The dressing of the walls is also very important. You really have to be particularly upright because afterwards we come compressed. So to prevent the wall from taking on some shapes, you have to be quite careful with the assembly. That's mainly the difficulty, but once you know how to do it, it becomes easy. In fact,
I forgot that now. You show me a bit of the framework, maybe stand in front and see that. Finally, please tell me briefly about the roof. You were telling me that in the high smooth, you did a bit like the floor, that is to say a box, and you isolated from what of cellulose?
So in the high smooth, which is therefore the peripheral push, we isolated with chêne voté. Okay, what is that? Chêne voté? The chêne voté, it's compacted hemp, well, not compacted into confetti, okay. And on which, in fact, we came to put a joisting, and it's this joisting that is blown into which we have blown what?
So there is double insulation, chêne voté.
The joisting is on the high rail to avoid creating a thermal bridge at the high rail level. So that's why we insulate the high rail, which it is peripheral. And on top, the ceiling is therefore insulated with cellulose.
And then on top of that, we have a mega frame with a mega roof. That it's you who made the choice, it's the architect?
No, it's the architect, so it's a bit the same design as the building next door. So it's true that it's a large roof that catches quite a bit of wind.
But we could have very well made a flat roof, for example, in ethylene propylene D in monomer or in saw tray. Something much lighter and much cheaper if we do it ourselves, for example.
Of course, or a pan roof or a single slope too, so in the end you
have insulation of the floor and roof with bio-based materials, or in a high room and all around straw, so also bio-based. Very, very little structure, mainly wood. Ultimately, it's the ideal eco-friendly house.
Yeah, there are still a few little panels floating around, but it's hard to do without panels when you say...
Panels, that is to say...
There is oriented strand board.
And that oriented strand board is not good, ecologically speaking.
It involves a lot more transportation. It's manufactured quite far away. So the panels, it's hard to do without them, but it would be nice if we could manage it one day.
Well, Cedric, over to you. You are the president of the Nebraska Association, which is in charge of building the building that is behind us. Can you tell us a bit about what you do and the role of the association?
Well, I am the president of Nebraska. Nebraska is an association comprising individuals with complementary profiles that we have strived to bring together. So we are two architects. Mathilde Lapierre is an architect and carpenter. And among the really active members, there is also Gilles Boustare, who is a structural engineer, and Peter Brown, who is a structural engineer too. Both of them are based in Switzerland. The Internal Study Office can calculate the load-bearing straw walls. Sami Ouem, doing civic service with us, is professionalizing towards load-bearing straw. And we try to federate the national network around load-bearing straw construction, with the aim of recovering all the work we have done in R&D, in collecting international scientific trials and making demonstrator buildings with it. So we try to make buildings that are proof, by example, that the load-bearing straw technique is effective and that we can fit into a regulatory framework.
Mathilde was telling me that you have already built about 10 load-bearing straw buildings, and you told me that your house is also made of load-bearing straw.
Absolutely. So for me, it's been... In the association, we've contributed to around 10 buildings. I have previously worked on over 20. And Peter Braun, he's one of the most well-known engineers after all. It's a microcosm. But Peter Braun, he's the engineer who calculated all the Swiss load-bearing straw buildings with the architect Werner Schmidt. He focused more on the big bales while we focused on the small ones. And so for a few years now, we've been pooling our skills to be able to size buildings with small bales.
So let's talk about ecology now, which is still the heart of a load-bearing straw house, isn't it? So how is a straw house ecological?
On several criteria. A bale of straw is agricultural waste. There is often confusion about whether something is agricultural waste or a byproduct. Of the 50 million tons that are produced per year, just straw, which is waste for us, there are 34 million that go for amendment for livestock. There are 11 million that go for soil amendment. Around 5 million are left unexploited, remaining a waste of agriculture. Currently, about 5,000 tons are used annually in France. So, we have a COEF 1000 of evolution of straw construction in France.
And there, for 5,000 tons, how many? How many houses are under construction? Approximately?
We estimate around 500 constructions annually. Not in load-bearing straw all combined, especially not for filling. Load-bearing straw buildings per year, they are made very little. Because at the regulatory level, it's very difficult to access the 10-year insurance. So for us, this is the point we really fought for, to get the 10-year insurance, to construct a structure that meets building codes and is legal.
So it's an abundant resource, which has a waste that insulates very well, which carries at the same time. And we said it when we saw each other the day before yesterday, but it also stores carbon. That's important.
It's a carbon sink because a plant or wood or vegetation to grow stores carbon to make its matter. As long as the vegetation hasn't burned again, releasing carbon dioxide, it has captured carbon from the atmosphere to create its matter. So it's a carbon sink. We have a thermal performance that is really very important. We are close to an R of 9. Passive buildings can be constructed using minimally processed agricultural materials that haven't undergone industrial transformation. We recover them via the Pro rules. We have the right to buy materials, straw boxes, directly from the agricultural world, and we qualify them ourselves on site so that we can use it as insulation within the framework of the Pro rules and as load-bearing insulation in the load-bearing straw.
So ecologically, would you say this is the top of the eco-friendly house? Or is it a form of eco-friendly house?
I think it's one of the forms of an eco-friendly house. Then, when we objectively look at the environmental impacts on pretty much the entire chain of wood consumption, water pollution, air pollution, we consider that it is still one of those that is the most advanced on the performers.
Let's now move on to the question of construction time. Mathilde was telling us that it takes about a week of work to put up the walls. Can you tell us a bit more about how long it took you to put this whole project together? Is it more of a quick construction type?
The load-bearing straw. Yes, I can add some additional information. It takes a week to put up the straw walls. Previously, it takes a week to make the wooden pieces, because in fact we say that it is load-bearing straw, but there are still wooden pieces that will make the chains, supports for the joinery, supports for the ceiling. We cannot directly place and fix a wooden straw bales. The connecting pieces take a week to make. Another week is needed to raise the straw walls and put the propeller on top. Compressed, therefore, to have a laser level on the horizontal chaining. For the third week, we are making the ceiling, insulate the ceiling, so with cellulose wadding, which is also an insulator, which is quite correct, which has good thermal performances that are consistent with what we do. And then there will be 2 weeks left to put the coatings on it.
The number of people varies from 5 to 18, depending on whether they are alone or in a group. The duration is 5 weeks.
Still quite a lot. After us, we have a site format that is a bit special. Is it that in fact, like the community of professionals who know and who can build under 10-year guarantees? In France is really extremely reduced. We are among the only ones, or perhaps the only ones today, to have a 10-year guarantee for building with load-bearing straw in France. And there is no school either to learn how to build with load-bearing straw. So in our projects, we have a component for the development of the sector. In fact, we welcome volunteers who are members of the association who come to learn with us. Although we are numerous, we don't move as quickly as a company would. 7 competent people on site with experience. So, in fact, out of about 10 people, we are between 3-4 knowledgeable people who... So we produce less, so we go much slower than if we were only 4, and we help others to produce. So at the beginning of the week, we don't move forward quickly at all. We secure everyone as much as possible, and we pass on the gestures. As the week progresses, people gain skills and knowledge
to do. And do you think it's a type of construction that is quite fast compared, I think, to the container house, the traditional wood frame house, or even concrete, you know? It's incredibly fast without necessarily requiring skills. At 28, there are only skills that you transmit, but we can do it in self-construction. A participatory construction site does not necessarily need to call on a mason to complete trades. We can do it ourselves in self-construction. As long as we can transmit, have the skill through your training.
For example.
In fact, it seems simple because we
take straw boxes and we stagger them. Like we would use brick, for instance. But to have a wall that is straight, well compressed, on which we can add a floor above, it's a whole lot. It's an expertise, in fact, that is learned, and it's a bit of a shame, I think, to improvise it. So it would be, I think, not risky on very small sites, but on sites that would be a bit large. I invite everyone to come and get informed. Really, there are books, there aren't many, but there are a few. Barbara Jones, a pioneer of straw construction in the United Kingdom, has written a book describing load-bearing straw construction in Europe. We are working on a best practices guide that may perhaps rise to professional rules. We don't know exactly the format yet, so we are in dialogue about that, and we are organizing a training. France offers various trainings with varying focus on design, engineering, and practical aspects. But it's really interesting to do at least one training and to go see or to find out before building a wall. Because in fact, there are a lot of gestures to learn, and for us, that's part of the interest we find in the technique. It's a know-how. We create skill jobs that are difficult to outsource because they involve mastering specific gestures.
So we saw that the load-bearing straw house is more ecological. It can be built quite quickly in a participatory construction site. The question on everyone's mind is the cost. Is it expensive, a crazy idea for the wealthy, or more costly than a traditional house? But is it cool because it's eco-friendly, or is it actually affordable? This type of project is for everyone.
Actually, there are several. The answer is not easy to give. It's not that I'm not going to give a price. I will give one. but it's that the walls in a house, so we did cost analyses on houses. The cost of a wall is about 20% of the price of the building. The overall project cost will depend more on the remaining walls. That is the type of coverage, type of joinery, technical equipment, foundations, types of floor. And these elements will really be the majority in cost compared to the cost. So we try to reduce the cost of the walls, but still we are not going to significantly reduce the cost of the house. If we have not affected all other items, we really invite everyone to look at their bills now. For a 100 square meter house, what are my energy needs for heating, hot water, possible cooling in the summer? How much am I going to have with such a solution? And say, well, annually, I'm going to save between 1,000 and 3,000 euros on energy. If I take this solution compared to that one over 10 years, it's between 20,000 and 30,000. And on the scale of the life of the building, well, the startup cost, in fact, it amortizes very, very quickly. And when we look at the slopes a bit, so the energy there over just the months that await us, I really think we need to change the vision a bit.
We need to think cost long term, that's for sure. And indeed, with straw bales, or you have a new R, you are so well insulated that I think there is no problem with the electricity bill. Let me give you a specific example, myself. I made a house out of containers, so I put my technopiles, my containers on top. I had for still 20,000 euros of containers for a little over 100 square meters. What about now? I had made a wooden slab on my technopiles and I had built straw walls. So instead of my containers, I would have made straw. Do you realize the potential cost? 100 square meters of two walls straws in the
containers there. In the announced budget, there are the finishes in me. It's
20,000 containers have arrived raw. I did nothing to the device, just the straw wall without the rest. What's left? We
have M2 prices overall straw wall, a straw wall as we build it. Most of the time it's a low list, staggered straw, a high list, and then a coating on each side. So when we are on a face coating, we are on an M2 wall cost, which depending on the size of the project, because we have economies of scale, if done manually, whether mechanized or not, the cost ranges from 250 to 350 euros per square meter of the wall.
Do you have an example of a construction that you have done where you can tell us that it was so many square meters and that it costs us so much in materials, at least? After the salaries of the people who worked on it, let's say that's extra, but in any case, in materials?
No. The materials, it's not very representative because in fact here, on what we do, it's almost everything. The budget goes towards work time transformation because in fact we buy raw materials, this construction site. Here, the straw bale, we have it at about 4 euros, so it's very expensive. The bale, it's the brick.
Literally what? 4 euros? Oh yes, and there, what is there? There are 7 in height.
There are around 250 bales on the side, I think.
150 bales at 4 each, so it's quite affordable.
Euros for straw. But after all, the budget goes into the processing time, the studies that go with it.
It's interesting because I started with the idea that straw houses were necessarily going to be cheap. And in fact, indeed, the materials are not expensive. That's what you're saying. But there is a technique that is still very little transmitted. And so you have to pay people to do it. And that's where the cost will be. But if we follow trainings, if we train ourselves and then transmit this technique, we will be able to build low-cost houses because
that's our key objective. Once we have the right tests and know-how, we can access them ourselves and buy inexpensive materials. And in France, self-construction is legal, so we also push for that. Straw door has structural issues not described in French texts. We want to address these when building one. At Satterbois, filled with straw bales, we can rely on 230 and 12. It's summer, EU houses at Satterbois, the DTU 3-1 carpentry. So everything is already well described everywhere. There are professional rules of straw construction. If we really learn them well and manage to apply them, if we have the tools, we can't follow the recipe, but we can always secure ourselves. We're currently working on developing load-bearing straw, but it's not available yet. We aim to share an accessible guide next year. However, as there are quite hybrid mechanical behaviors, in fact, there are load transfers that will pass. Sometimes in the straw, sometimes in the straw plus plaster complex. Sometimes in the pre-cases, so there, it's the design office structure, in fact, where there is a small budget to put on this side there. So really do not exclude studies. So studies are not necessarily expensive, but in any case, they are a bit important to be able to build behind. And
thank you for presenting this beautiful project. Perhaps we'll collaborate on another house in Saterpais. I believe this subject deserves further exploration. I will provide numerous sources in the video description. I hope you will give me links, things that I can add to share a bit with all the people who are watching us. If you have any questions, feel free to ask in the comments. We'll do our best to answer them. Maybe you will take a look under the video to answer people when you have a little time outside of the construction sites. And then thank you for watching this video until the end. I hope it interested you, that it brought you a lot of knowledge. I'll see you soon on the channel. It was Julian and Cedric. Goodbye.